We've got another example where they're asking us to find the limit of a given equation. As soon as I see a square root in this equation, I really know that I'm going to be using my square root method on this problem, probably 99 times out of 100. But I can't stress to you enough that you always have to try option one. Just as you get lazy with it, they'll give you an easy one. They'll give you a gimme point, and you'll miss it because you're like, no way could that possibly be just plugging it in. So always try option one, plug it in. So take whatever that x value is that you're headed towards, and you just plug it into that equation for x everywhere. And so whenever we go to plug in a value, that's when we get to drop our limit statement. And so what we'd end up finding out real quick, we could have seen it just by looking at it. The top's going to give us 1 minus 1, that's 0. More importantly, the bottom gives us 0. So anytime we get division by 0, that is bad. And so we know that option 1 is going to fail us in this situation. So we look to our other limit options. And as soon as you see that square root in this problem, you just got to be telling yourself, this is that square root example, and to do that problem, we always do the same thing. We are going to rationalize it. So we're going to rationalize this and get rid of that square root on top. So rationalizing is just a fancy way of saying get rid of the square root. The process for getting rid of a square root is you always want to multiply by the conjugate. So multiplying by the conjugate, you're going to multiply whatever piece has the square root. It could be on the top of a fraction, it could be on the bottom of the fraction. It doesn't matter. What matters is we need to rationalize whatever that piece is with the square root by multiplying by the conjugate. Conjugate is, again, fancy math talk, which is just saying change the symbol in the middle. If that was a plus, I'd make it a minus. It's a minus, so I'm going to make it a plus 1. And then to keep everything straight, whatever we do to the bottom, or whatever we do to the top, we got to do to the bottom. We always have to multiply by the same thing on top and bottom. Now we're just going to start putting this together. So we're going to simplify this out. Keep your limit statement coming with you through this whole process, right, until you get to plug it in again. If you look at the top here, this is distribution is what you need to do. A lot of people refer to this as FOIL. We're looking to multiply these two pieces together. So we would take the square root of 6x plus the square root of x plus 6 times the square root of x plus 6. When you multiply square roots that are the same together, they cancel each other out. So really we would end up with x plus 6. Then taking that square root of x plus 6 and multiplying it by 1, and we get plus a positive square root of x plus 6. Done with that piece, now we're going to go to the negative 1 and multiply it through. So negative 1 times the square root of x plus 6 is going to get us negative square root of x plus 6. And then negative 1 times positive 1 is going to get us a negative 1. On the bottom here, do not multiply these things together. It's the biggest mistake that a lot of people make on this. You just get into the pattern of foiling everything you see. And in this situation, it's going to mess up what we want to keep our eye on, which is this plus 5 down here that's kind of doing us in. What you should see happen every time, if you did this process right, is these square roots in the middle should cancel. I've got a positive square root of x plus 6, negative square root of x plus 6. Those conveniently cancel. And then as we go to rewrite this now, we can sort of combine some like terms on top. So we get limit as x approaches negative 5, and then that 6 right here minus a 1 down here, so we're going to end up with x plus 5. And then on the bottom, oh, look what we conveniently have. It's x plus 5, and then all this other stuff, which we don't really care about right now. But you can see that had you multiplied it together, you would have missed that, guess what? We get to cancel now. X plus 5 on top is going to cancel with x plus 5 on the bottom. So that trouble spot canceled out for us. So rewriting what we have, limit as x approaches negative 5, that's now going to be a 1 on top because we canceled out the x plus 5. And on the bottom, we're left with the square root of x plus 6 plus 1. After you do that process, after you get that sweet cancellation to happen, guess what? You're back to option 1 again. Try plugging in your x value. So our x value is negative 5. We plug it in everywhere we see an x. It's at this point that we finally get to drop off that limit statement. So I plug in negative 5 plus 6 plus 1. So on the top, I get 1. Negative 5 plus 6 is 1. Square root of 1 is 1. 1 plus 1 gets us 2. So our answer here is 1/2. So the final answer to this question, the limit as x approaches negative 5 of the square root of x plus 6 minus 1 over x plus 5 is equal to y equals 1/2. That is the answer to our limit question. And remember, every time we see these square roots, the process is always the same. Multiply by the conjugate to rationalize and get rid of your trouble spot.